Hey y'all, my name is Tyler Buckley. I'm a graduate research assistant in the Rangeland Wildlife Lab at the Range Cattle Research and Education Center.
Hi, my name is Bethany White. I'm a research biologist with the Wildlife Ecosystems Lab at the Range Cattle Research and Education Center. Today we're going to talk about telemetry, how it's used to track different types of wildlife, and specifically how we use it to track wild pigs.
Ever wondered how it all works? Your television, your email or internet, and even your cell phones? They work by sending signals. So through the air, like for a cell phone, or even underground over cables for your internet and television. This process of sending information is called telemetry. In radio telemetry, transmitters send signals that are picked up by a receiver. So let's say you're driving and you want to listen to Country 99.9. You'll tune your radio in your car, and that'll act as a receiver. The radio station tower will act as a transmitter, sending the music to your vehicle. In wildlife telemetry, an animal wears a transmitter that sends a specific signal, and then the wildlife researcher uses a receiver to try to locate or pick up that specific signal and track the animal.
In wildlife tracking and telemetry, VHF transmitters are used. VHF stands for very high frequency. So the animal wears a VHF transmitter, like this pig collar. Then the researcher uses a receiver with an antenna to scan for that VHF's specific collar's frequency or signal. This collar is 166.621. So when the receiver picks up an animal's frequency, they're going to hear a slow pulse of beeps, as we'll listen to now. So those beeps allow the researcher to determine the general location of an animal, and then they can actually do more to pinpoint the more precise location of an animal. So let's watch Tyler try to locate a couple of pigs that have a VHF collar on them.
Here I have a Yagi antenna and a receiver, which is used to pick up frequencies of a VHF collar. I tune in to a specific frequency and I start in a specific cardinal direction. As I rotate the antenna, I listen for a signal. No signal is heard. The pig may be too far to be heard. I just turned to frequency 166.631. So here I'm going to listen for a pig. Here we have a collar, as you can indicate by the slow beeps. This pig is within likely range.
Researchers will also use what's called triangulation. So if the researcher picks up the deer at one location, he'll draw a line of direction towards the animal, then move to another location and draw another line of direction towards the animal. The lines of directions meet where the animal is then located. Researchers also have to be quick, as the animal might move or use two people.
So some of these collars, they have the option of having what's called a mortality sensor. So if a collar doesn't move, let's say it's fallen off a pig or a pig's actually died of some natural or unnatural causes, we can set it to tell us if this collar has been sitting for, let's say, 4 hours, it's actually going to give a different pulse rate. It's going to change to a double beat, which we can listen to here. So when a researcher hears that, they need to go determine if the collar has fallen off of the pig. Either it's slipped, they've lost weight, or the pig has actually died. So that's one of the biggest things about VHF is it allows us to track the pigs still have the collar on, their general location, whether they're on or off the ranch, and whether they may have actually died. When we hear a mortality signal in the field as a researcher or technician, when we hear a mortality signal, then our job is to either go find that lost collar or either flush a pig, because pigs actually take really long naps, as we found out. So now we're going to watch Tyler and some examples of him trying to locate a pig collar that's either off or on of a pig.
Found it.
So here we are in a Florida oak hammock with a wetland nearby, and we're trying to track down a pig. We've actually gotten a mortality signal on this pig. However, they can often just be taking a very long nap. So we're going to see if we can track this pig down and flush it or find a collar. So if you can hear, we're getting a double beep, which indicates possible mortality. We're trying to hone in on the direction here.
It sounds like the pig is in this direction.
Maybe got a little. So today researchers use VHF, but usually in combination with a GPS collar or some kind of GPS device on an animal. So not only are we tracking the animal with telemetry, but we also have a GPS system in it that's going to record the animal's location and movements at a set interval time. So you might tell it to record a GPS location every 10 minutes or every 30 minutes. But we also still have that VHF transmitter in here that allows us to keep track of the pig, whether it has the collar on or any mortality signals or slip collars. So the GPS receiver is more recent and actually lets us record the location and the movements of the animal.
The GPS receiver works by communicating with multiple satellites, and then similar to triangulation with the VHF, the GPS receiver actually records the location of the satellite, and that allows it to determine its own location. The most basic GPS is called a store on board. It records and stores the data. Then the researcher has to recover the collar and download the actual location. More recently, satellite GPS or GSM is used to send the data via satellite or a cell signal and the researcher simply gets the data over the internet.
So at the Range Cattle Rec Center, we use telemetry to study wild pig populations. So we use the GPS and VHF collars on individual pigs. We track them every about 2 weeks using VHF telemetry to assess whether they're on or off site, whether they slipped a collar or possibly died. And then we use our game cameras to re-site marked and unmarked pigs. And so this gives us the ability to estimate habitat use, home range size, which is the area that an animal is actually living in and occupying. And we also do removal efforts, so trapping removal efforts, and then we can assess before and after population densities. A lot of other animals are also used by researchers to track their movements and habitat use. A couple big ones used in Florida is the sea turtle. They are often used to monitor to see their movements and track their nesting locations and success. Bats are also monitored, and things as small as butterflies even have GPS tags and telemetry devices on them. Another important species in Florida is the Florida panther, as well as our deer population that is often monitored using GPS and VHF telemetry. So all of this telemetry helps biologists answer questions about how an animal moves throughout their landscape and how they're using different habitats. And that in turn helps us work on conservation efforts.
That's all we have for you today. Thank you for joining us for the Wired Wildlife 2020 Virtual Youth Field Day. Please check out these websites if you want to learn more about different GPS studies, and we'll look forward to taking some questions from you in a minute.